Theorem number 2 talk about here today is the mean value theorem. And it's similar to Rolle's theorem. It's got a couple of hypotheses, and then the conclusion is similar but different. Okay. All right, so here it is. Let f be a function that satisfies these two hypotheses. There's only two in the mean value theorem. F is continuous. On AB, and F is differentiable on AB. So in a sense, it's much less restrictive because there's going to be a lot more application, I guess, of that because you don't have that third part. But it does still have to be continuous, and it has to be differentiable on the interval in those places. Okay? Well, the conclusion then is, then there is a C in the interval A to B such that f prime of C equals f of B minus f of A over B minus A. Okay. Now, just looking at those two, do either of those two ring? Well, this one should definitely right here. That's slope, right? Slope at C. Tangent line slope. Now, does this one look vaguely familiar? That's slope between 2 points, right? And the 2 points are the points associated with A to B. Yeah, that's just the slope formula, isn't it? Okay, so let's see what that means graphically speaking. So here's what we've got. So f of A and f of B don't have to be the same. So here you've got A, and there's f of A. And then since B doesn't have to be equal, let's just put it up here. F of B doesn't have to be equal. So that f of A and f of B don't have to be the same. All right, so we've got continuous, we've got differentiable. And so it just means there's no corners, there's no breaks. You're just going from A to B somehow or another smoothly. Continuously, nicely between the two, okay? And you can do a lot more stuff. I mean, that's just one way you could go, okay? What does this mean? Well, first of all, let's take this. F of B minus f of A over B minus A. We've already established that's just the slope of the line basically between these 2 points, right? It's the slope of the line between the point at A and the point at B. So that the slope of that equals f of B minus f of A over B minus A. Okay, so what is this this other part? Well, that's saying there's some C in here that equals that slope. Where would that be? Well, think about your tangent. It wouldn't be here, wouldn't be here. It's going to be somewhere up here, isn't it? There's going to be some value C, which it looks like it's right about there, where you've got a parallel line to that, parallel tangent line to that. That's what that's saying. Make sense? That's what it means. There's some tangent line at C that matches the slope from A to B. Now there may be more than one, like we had on Rolle's theorem that I drew, that one where we had lots of horizontal tangents, but yeah, let's say you're going, here's A to B, and we're going, maybe it does a little more stuff. Well, that just means then, here's your slope of from A to B. In that case, what about that? There's probably going to be a couple, isn't there? You can go right here. Let's see, that looks like a pretty good tangent there, parallel to it, and then down here we'd also have another one. So in that case, we'll have maybe a couple of C's. Okay? All right. So let's do a couple here. One of the types is this. Okay. Let's say we've got y equals f of x graphed here. And we're going to put 2 and 5 on it. All right, so let's say f of 2 is 3. F of 2 is 3. And then f of 5, let's put that up at 7. And we're going to peek it out there, and then something like that. Okay, so estimate for me there. The value of C that satisfies the conclusion of the mean value for 2 to 5. Interval 2 to 5. Estimate the value of C that satisfies the conclusion of the mean value theorem for 2 to 5. Well, I mean, you get as accurate as you want here, but I would just draw. Let's just draw in the slope, the line between them, and try to see whereabouts C would have to be there. Satisfy it. Where are you thinking? It's probably not going to be before 4, is it? Looks like to me it's somewhere between 4 and 5. Because here, if I do any slopes here, they're all negative, and I need a positive slope. So it's definitely on this side of it. And the other thing is, I can't go back here either because it's got to be in the interval 2 to 5. So it's somewhere between 4 and 5, wherever you want to put it, I guess. There would be a little too much, so let's get a kind of a middle ground there. So we get parallel to that. Yeah, I'm thinking along about there, which is whatever you want to call it, 4.1. Probably a little more 4.1. How about 4.2, 4.3? It's an estimate, so yours may look something different, but it's definitely somewhere between 4 and 5, and I'd say it's less than 4.5 also by my drawing. Okay? Is that okay? All right, well, let's get a little more precise here, and do this one. Verify that the function satisfies the hypotheses of the mean value theorem on the interval and then find all values of C that satisfy the conclusion. Sound familiar? That's what we did with roles, wasn't it? Same idea. And this is our function. Number one. We'll do two of these. Number one, f of x equals x squared plus 4x plus 5, and the interval is 3 to 7. Okay, so the first part, verify the hypotheses. Okay, what hypotheses do we have for the mean value theorem? We just really have the two, don't we? F is continuous on A to B. Well, again, that's continuous everywhere. No problem, okay? So F is continuous for all real numbers. It's definitely continuous 3 to 7. All right, number two, F is differentiable on AB. Open interval AB. Is that true? Same thing. F is differentiable everywhere for all real numbers. Okay, check, check. Hypotheses done. Okay. All right, well, what do we then do? Well, then we satisfy the conclusion. Need a C that satisfies the conclusion. The C that satisfies the conclusion is I need an F prime of C equal to F of B minus F of A over B minus A. I need to find a C that does. Well, think about it. I need to start here. Start with the slope. I need to calculate that because then that's what I'm going to set my derivative up to be equal to. With me? Yeah, start here. F of B minus F of A in this case over B minus A is, what would that be? Well, this is A, this is B. So it'd be F of 7 minus F of 3 over 7 minus 3. Yeah, just figure those out. F of 7, that'd be 49 plus 28 plus 5. 33, is that 82? Right? Is that 82? That's what you got. Okay. F of 3 then, F of 3 would be 9 plus 12 plus 5, so that's 26 over 4. So it's 14. 56 over 4 is 14. So that's what F of B minus F. Okay, so now I want to find such that the F prime of C equals 14. What does that mean? Well, that means I'm going to have to set the derivative equal to 14. The derivative here, what is the derivative? F prime would be 2x plus 4. So I just need to put the derivative, 2x plus 4, equal to 14. And that'll do it because then I just subtract the 4. 2x equals 10, divided by 2, x is 5. What does that tell me? That's your C. And it's good because it's in the realm there, isn't it? In the range. The x is 5, so that C, that's what I want C to be. Okay? Not too bad. So that's the one where your slope would be 14, which would match the slope between those two points. Okay? All right. Any other question or concern? All right, let's do number 2. Same thing. Verify the hypotheses, find the C. F of x equals, in this case though, x minus 1 over x minus 5. And the interval we're on is 1 to 4. Well, you might be thinking, whoops, I see where it's not continuous here, so are we going to run into a problem? Well, here's the thing. All right, so the first thing, verify the hypotheses. So number 1, f is continuous a to b. One to 4. Well, the thing is, f is not continuous at a point or at a value, isn't it? But we're still okay because where is f not continuous? F is not continuous at 5, right? Making the denominator 0. We're okay because we're not getting to 5 there, are we? And that's they only only at x equals 5. F is not continuous at only at x equals 5, so it is continuous on 1 to 4. So we're okay. Does that make sense? Number 2, f is differentiable from a to b. Same thing, isn't it? Where is f not differentiable? Well, it's the same thing. It's smooth everywhere else. Think about it. But it's broken up at 5. So there's not a differentiable at 5. So f is not differentiable again at 5. X equals 5. But that's okay because we're only going 1 to 4. Yeah. All right. So we're okay. Now if that had said 1 to 7, that would have been a problem. The hypotheses would not have been satisfied there, but it's okay. All right, well, what do we want to do with that then? Find the C that satisfies the conclusion. So how do we do that? Well, like we said, start with the slope, the f of b minus f of a over b minus a, which in this case would be f of 4 minus f of 1 over 4 minus 1. See what we get. All right, so 4 would be 4 minus 1 over 4 minus 5. That works out nicely, doesn't it? 3 over negative 1, negative 3. Minus f of 1. That's real nice. 0 over negative 4. That's 0. And then over 3. So it'll be negative. Hey, that's really good. We chose wisely there. So the f of b minus f of a over b minus a stuff is negative 1. All right, well, okay. What do we do with that? Well, the conclusion says there's an f prime of c equal to this. So I need to set the derivative equal to negative 1 then, don't I? So let's get the derivative here. Now that's a little bit more work on these. Okay, so it'd be quotient rule. Low d high minus high d low over low squared. But it works out pretty good here. That's just x minus 5 minus x plus 1 over x minus 5 squared. So that's the x's cancel. So that's just derivative negative 4 over x minus 5 squared. this is telling me I want the derivative equal up to -1. So let's set that all equal to -1. Derivative equals -1. With me? How would I solve such a thing? How would you solve it? Huh? Multiply both sides by x minus 5 squared? Okay. I think that's what I'd do too. Because that'll cancel that out. Let's see. That'll give me -4 equals, and then I would, of course, square that out. So it'll be -1 times x squared minus 10x plus 25, wouldn't it? X minus 5 twice. And so that would be -4 equals -x squared plus 10x minus 25. Distributing the minus there. Well, that's just a nice little quadratic, isn't it? Make one side 0. Now, it might be easier to pull that over there, push that one over there, but with the minus x squared, I suggest we put these over here. So I'm going to go add x squared, subtract 10x, and then add 25, so that would be plus 21. You can do it the other way if you want, but then I factor. Yeah, this is, I think why I did this one also. Factor, you got x and x, 7 and 3, don't you? Both negative. X minus 7, x minus 3, so that's x equals 7 or x equals 3. Either one of those work? Sometimes there are more than one that works. No, just one of those works. Just one of those works. Which one? Which one's my C? 3. Why 3? Because I want it in 1 to 4. If it had said 6 to 10, something like that, maybe. I don't know if that would have been the right one, but we'd have gone to 7. But yeah, this is the one we want. We want 3 because it's in the interval 1 to 4. Okay? C equals 3 would satisfy our conclusion. All right. Let's say we have f of x equals f of x equals the absolute value of x minus 1. Is there a C in 0, 3 such that f prime of C equals f of 3 minus f of 0 over 3 minus 0, which is the conclusion of the mean value theorem? Well, let's think about that. Well, first of all, let's just see what this is. F of 3 minus f of 0, 3 minus 0. Okay. So f of 3 would be 2, wouldn't it? Let me just write that here. All right, so with me, f of 3 would be 2. F of 0 would be 1, so minus 1 over 3, 2/3. 1/3, sorry. 1/3. So the question is there an f prime equal to 1/3? Well, is there? Let's think about this. What is f prime here? Remember how we did those? This, nothing else reminds us of this. Remember how we did the absolute value derivatives? Didn't we do the the piecewise? We did x minus 1 and then minus x minus 1. Remember that? Yeah. And this was if the corner's at 1, and so the break would be at 1. So this is for x is greater than or equal to 1. This would be x is less than 1. So what's the derivative? Well, if x is greater than 1, what's the derivative? What derivative? 1. If x is less than 1, what's the derivative? Negative 1. So back to the question. Is there a c in 0, 3 where the derivative is 1/3? No, because the derivative is only ever 1 or negative 1. That's the only value. So that's a big fat no. Okay, why then doesn't this violate the conclusion of mean value theorem? Because mean value theorem says there is something, there is a c that gets to that. Why doesn't this violate it? Well, it gets back to the hypotheses, doesn't it? What hypothesis is not satisfied for this? It's not differentiable, okay? F of x is not differentiable where? It's continuous everywhere. I mean, there's no break right here, right? Because here's f of x equals, let me draw a little bigger. I said it a while ago, but yeah, it's continuous everywhere. It's that V shape, shifted one to the right, but it's continuous everywhere. There's not a break in it anywhere. However, what is that? Corner? What do we got at corners? No differentiable, right? So it's not differentiable at x equals 1, which is in, just so happens to be right in the range there. So yeah, if there's anything that doesn't work, whether it's one of them or two of them or whatever hypothesis, if one of them's broken, then the hypothesis is, the theorem is off.